enough people now, and let's get started. I'm so excited to invite Gerard Espona on this show. He is one of the contestants in OpenCV AI Competition 2021. And he's been amusing us with some great video demos with a robotic arm called Kauda. And the name of the team is Kauda as well. Let's just join together, and a big hand for Gerard. He's going to show us some amazing stuff right now. Also with us is Phil Nelson, as always. He's going to organize, he organizes all these events for us. He's the content manager at opencv.org. And say hello to Phil as well.
Hey, everybody. Don't forget, we will be doing Q&A at the end of the session, and there will be some trivia where you'll be able to win something cool. Satya, what do we got this week?
We got, again, 200 free hours from Microsoft on Microsoft Azure. And as you know, that the competition, OpenCV AI competition, is sponsored by Microsoft and Intel, and so is this episode. Let's go over to Gerard. We can start with an introduction first, and then we will jump into the, the details of what you have to present today, the digital clone.
Hi. Hi, everyone. And first, well, it's a pleasure to be here today. So, yes, my name is Gerard Espona. I'm a computer science engineer with 20 years experience on software development. And some of this experience is related to computer vision and augmented reality. And I'm the half of the Kauda team. And yes, I prepared a small keynote, so maybe I can share the screen.
So one thing that, people who are just joining, the things that we are going to learn in this, you will see a cute robotic arm. We will see how OpenCV AI Kit has been integrated with Unity. And Gerard would also talk about how, these 3D virtual environments like you can create in Unity can be used not just for gaming, but also for computer vision, reinforcement learning kind of applications. So let's get started.
That's a great, great summary. Yes, so again, thanks for this opportunity to explain about the Kauda project and our submission for the contest. About the session today, you can see, hopefully you can see the keynote. It's it's quite short. So because Phil was suggesting this very bad idea of to do live demos. So
once again, allow me to say muhahaha.
Yes. So I will try to keep the keynote around 25 minutes and then play a bit with Unity. So if the laptop is also working fine. So, okay, so yes, the title of this session is Creating Digital Twins with OpenCV AI Kit and Unity. And first, I want to introduce very quickly about the Kauda team. So we are a duo team. Giovanni Lerda is industrial engineer and who is designing and developing Kauda robotic arm. And then myself, I'm in charge of the software development. Okay.
And I love this because Giovanni is in Italy, you are in Spain, and you're collaborating on a hardware project remotely, and they have never met each other. So that's the new normal, I guess. With COVID, etc., people can collaborate on very difficult projects, but ever meeting in person. So that's fantastic.
Exactly. That was our case. We met last year, and with all this COVID situation, obviously we are kind of close geographically, but we never met physically. So, but we are collaborating in this interesting project. So I want to explain quickly what is Kauda. So as you can see, it's an open source 3D printed desktop size and 5-axis robot arm. So you can see here in action. What it means is open source, so you can go to the website and you will find everything you need to build your own Kauda. So that's why I have one over here. And from the STL files to the electronics schematics, everything. And 3D printed and desktop size, it means it's very affordable. So as you can see, you can print all the robot with one roll of PLA. So it's really very cheap to do it. That's why we believe this project is really perfect for anyone who likes robotics for education or to do some research and development like we are doing on our submission a bit. So the video is on the website also, so not going to see all the video. And then, yes, so about our submission, we like to say is to bring Kauda to the next level with spatial AI. So basically, we want to enable computer vision tasks. We want to enable also collaboration between Kauda and human agents to perform more complex tasks. And the main topic is to enable reinforcement learning with the robot.
One quick question before we move to the next slide, Gerard. If you go to the previous slide, can a beginner who has no experience with robotics, is this a good platform to get started with, an arm robot kind of thing?
For me, it's the best because I'm good in software, but I'm very bad building things. So, and if I was able to build one, anyone can do it. But definitely, so and that's why I think the desktop size it's helping. So it's really a small arm robot.
Yeah.
5 axis is enough to give a lot of freedom, but it's not really complex. So it's using 4 stepper motors and 2 servos. Mm-hmm. And it's using one Arduino on the electronics. And you have all the schematics and everything in the website. So how to connect the motors and everything to the Arduino. So really, yeah, so really I think it's the best for anyone who wants to start with robotics. It's great.
Yeah, and it's also, you mentioned that Giovanni, who's an industrial engineer, he designed the robot to begin with. And the files, you downloaded the files and literally 3D printed the robot that you have he did not ship it to you. You actually built it using the information on the website. Is that correct?
That's correct. Exactly. Okay. So that's nice. That's that. You can find in the website of Giovanni or in Instructables. So you have step by step. And in fact, I was building the robot before meet together. So, and honestly, yes. So you go step by step, and at the end you have your robot. Of course, Giovanni will love to answer if you have any question or whatever. But
can I ask about how much it costs, like all the parts, excluding like the 3D printer, of course, but.
Yes, I never did the exact calculation, but one roll of PLA is around, let's say, 10-20 euros, and then the NEMA 17 servos is maybe the most expensive part. Is around 20 euros, and the Arduino 20 euros more. So I would say gross estimation with 80 or 100 euros max, you can build the full robot. So it's really, well, I would say it's really affordable.
Nice. So I have an 11-year-old son, and this could be his summer project.
Yeah, I mean, that's less than $100 US for anybody who doesn't want to do the conversion.
Yeah, it's the same. I have 2 kids over here, so 14, 10, and they enjoy a lot.
Nice.
Okay. So yes. So I was explaining about our submission. Anyway, today we will focus in the concept of digital twin. So we are not going to talk about reinforcement learning and so on. Digital twin at the end is the core thing that allows us to develop our submission. So I think it's interesting to talk about this concept. And probably, so the question, what is a digital twin? This is a very general definition, but I think is quite good. So at the end is a 3D virtual object with two main properties. So the first one is the digital twin is directly connected with the physical counterpart, with the real one. So this is important property. And the second one is the digital twin. Usually it's an accurate simulation of the real one. So then depending on how is built this connection between the digital twin and the real one, we have these several levels of maturity that enables different kind of applications. If this connection is one way only, or if it's bidirectional, and so on. Anyway, this is very general definition. It's not only applying to robotics. In fact, it's applying to many industries, markets, verticals. And the definition could slightly change depending on the case, okay? So, but let's focus on robotics. So why we think it's interesting to have a digital twin in robotics. So first I want to mention that if you build a digital twin, so a 3D virtual objects that mirrors a real one, usually you have a 3D environment to interact and visualize. So in our case, we choose Unity. So I will explain a bit more later, but it's a popular video game engine. So you have this 3D environment, so it's important. Then why it's interesting to have digital twins? Here I listed several options, but you can imagine in industry is easy to think that it's often easier to work with the digital twin than go into the factory with the real robot. So working with the digital twin is much easier in this 3D environment.
Yeah, and it can be very expensive also, right? I mean, some of the robot that you have, it's not expensive, but industrial robots can be very expensive. You cannot even find time on, even if your company owns one, you may not be able to find time on it. And let's say you want to have 5 different teams working on this, it's impossible to give them time on the robot. So simulations are the way to go in that case. You do most of the things in simulation and then try it out on the real robot and make corrections, right?
Exactly.
I think there's also a cool, like improving human safety is another one of the goals of Oak. And there's a lot of crossover with jobs that are just not very safe for humans to do, that it's much better to have a digital twin like this.
Yeah,
exactly. So in fact, yes, and the rest of the points are kind of linked. So for example, thanks to this 3D environment and visual environment, for example, allows people without coding skills, for example, to program tasks for the robots, for example. And then visualizing and interacting with the robot in this 3D digital environment could be enhanced very easily with augmented reality, mixed reality, and virtual reality for several use cases also for programming the robot to do maintenance, for example, or to train people in VR on how to build or how to maintain about the robots. Yeah. So I will show some examples later with Kauda Digital Twin about this.
Actually, there is this story from Microsoft that when Bill Gates created an operating system for I I cannot remember the name of the first, Altair. I think it was Altair something. I forgot the exact model name. That was the first microcontroller based computer. I mean, if you can call it a computer. It was, you still had to, you could program it and then you can see the results as LED lights. And that was the first contract they got. The only thing is that they did not have a physical machine with them. So they coded everything based on the specification that was given to them. So the software, the whole operating system was created without them ever testing on the actual device, which is fascinating. But it happens all the time in this, when you create digital twins, that you create something for using the digital twin, and then you go, there could still be a lot of differences. But in case of Bill Gates, this thing worked perfectly. Like this thing actually output the result. So that's something fascinating. Similar, not the exact same thing, but similar story.
Well, but that's a good point, and that's why I highlight the point of the digital twin should be an accurate simulation of the real one, of course, because then when you connect or when you go and work with the real one, if it's not real accurate simulation, then yes, you can have some surprises or yes, unexpected results.
Yeah, especially if something happens to the paper tape in transit.
That's right.
Okay, so yes, and last but not least, closing this topic, if you try to enable reinforcement learning in robotics, so because you have this virtual environment where the agent is learning, really digital twin of the robot is a concept that is rising very natural. So that's also important to highlight. So, well, and before checking in detail Kauda digital twin, why Unity? So we choose Unity. As I explained, Unity and Unreal are very popular video game engines. So just 3D environments to develop usually video games. But I want to, so I want to highlight that at least during the last 5 years, Unity is investing to enable other use cases for the 3D engine, especially on robotics, AI, and computer vision. So here I listed some of the packages. So for example, we have ML agents, is a Unity package to work with reinforcement learning and Unity as a virtual environment. Really, I want to recommend if someone wants to start in this exciting field, that's reinforcement learning, to check out this package, because it's very easy, it's very visual, so it's very easy to learn the core things about reinforcement learning. They have about 18 examples, different tasks, different agents, different policies, the reward system for each one. So it's really nice. So then we have Unity Robotics with ROS integration. And we have Unity Perception also. It's a computer vision package to generate synthetic and ground truth data. So that means in few minutes, you can generate a huge data set of synthetic images, but also you have this automatic labeling for you. So it's really very nice. So, when you try to train a custom model, a big pain point is the data set. So I want to show you quickly.
One quick question, Gerard. Yeah. So these Unity robotics, perception, cloud simulation, etc., is it by the Unity team or is it by the community?
It's led by Unity team. Nice. But most of the time, they start very early sharing their repositories in GitHub and where you can contribute also. but it's mainly driving by Unity.
I've been dropping the links in the chat for folks, and we'll put those in the YouTube description when we upload this as well.
That's
yes.
great. Yeah.
Yes, I want to show quickly an example. So you don't see, let me share screen. Okay, so let me share the browser. So just to give an idea, because this is a very nice example and a bit a summary of these packages. This is a very recent post from the Unity team where they were using this perception package to generate all this synthetic data about around a cube.
Yeah.
Okay, so changing the lighting conditions and several other features. And they were using this synthetic data to train an object pose predictor.
Nice.
So so then the robot can do a pick and place task on this with this cube. Okay, so well, in a way, it's yes, it's interesting, and keep in mind because I will talk a bit later about this topic. So let's back to the keynote. So okay, so then maybe we can check in detail. So Kauda digital twin. Okay, if we revisit the definition, how it looks like. So obviously it's a 3D virtual Kauda. Okay, so it's fully functional. It's an accurate simulation. And on top, we added inverse kinematics control just to make it easy, control the whole robot from using only one point, so you don't need to care of all these 5 axes. And obviously, we can connect the digital twin with the real one using USB or Bluetooth. And of course, we support OD devices. So I want to show here some examples of how to enhance this interaction and visualization using augmented reality, virtual reality. So the first one is, you can see, for example, this is a virtual reality application to get familiar with the robot. So to get familiar with how it works, the axis and everything. Here you can see the digital twin on the left and the real one in the right, and how manipulating the axis on the digital twin is connected with the real one. So here is another virtual reality application to play around with the inverse kinematics concept. So you can see moving only the cube, I can control the whole robot without caring of each axis itself. So it makes it easy to control the robot. Here, controlling the robot with Oculus Quest controller. And the last example is an augmented reality application where you can see the digital and the real one. So, okay, so that's basically Kauda digital twin. And okay, if we go back here quickly, what about spatial AI? Because we want to enable, we want to connect at the end of devices to Unity. So this is the second part. In fact, it was the main first blocker for our submission. So, okay, we have Kauda, we have digital Kauda, but we want to connect OD inside with Unity. So here I want to mention that Unity is built on top of C#. So it's possible to connect for example, from Python, but usually you need a kind of client-server architecture with 0MQ or something like this. So I was not very fan of these kind of solutions. The other option is to build a plugin. That basically means to create an interface from C, C++, and C#. Okay, and that's the way we go. At the end, it requires more effort, but at this point, I can show you several examples. So here is the face detector pipeline. And thanks to the plugin, you can see I can get the preview image here inside Unity and some metadata. So I can control the side plane with my face. So and yes, and this second example, it's similar, but using a second two-stage pipeline head pose. So I'm using the head pose to animate this character. So you can see here the metadata. So I'm using the yaw, the roll, and the pitch to control this. So okay, so up to here, cool. Yes. Yes, it's difficult not to have fun inside Unity, honestly. So, okay, so up to here, we can say we solved this main blocker, first main blocker for our submission. So it was cool. Then we got this request to why not to create a virtual oak camera inside Unity, especially for the topic we talked about generating synthetic and ground truth data. And obviously, well, it was a good idea, so we implement. But you can imagine, so pushing a bit more the concept, yes, why not to have an oak digital twin of the real device? That makes a lot of sense because then we can have, okay, we have an oak digital twin for Kauda digital twin. So it's kind of this meta twin really mirroring the real Kauda with the real camera. So it makes a lot of sense. So we can revisit again the definition of digital twin and to see how should look like the old digital twin. So obviously it's a 3D virtual camera. It's an accurate simulation, especially because we want to generate synthetic data, for example, to train custom models. So we use the field of view, resolutions, and specs in general from the old devices to set up the virtual cameras. Yeah. And obviously we want to connect the digital twin with the real one, but not only in one way, like getting the preview and some metadata. We want more bidirectional connectivity. So this enables us two kinds of applications. One is then we can create pipelines directly inside Unity, just with few drag and drops and load in the device. And the second application is to feed, we can feed the real device pipeline with the virtual camera images. So this is quite interesting for the same reason. So at the end, if we say we solve this main pain point of generating synthetic data to train your custom model, but imagine we are talking about you building a system for autonomous car driving or drone flight, where the training data set is huge and the environment could be huge and a lot of different kinds of conditions. So it will be very nice to do the first initial validation of your models in real time inside Unity, where you can control all these conditions in real time.
Yeah. It sounds like you've basically created the computer vision Unity version of the movie Inception.
It's very difficult to explain, yes.
So one other thing I want to point out that, when we do these things virtually, it is not just that, oh, you may be thinking that, okay, you have this virtual camera, but I also need to create a virtual scene to use this camera, and that's going to be expensive. But the fact is that there are so many creators of these virtual scenes, so many simulators, etc., that might have been created that you can use or buy. Either way, it is much less expensive to once you have something built in simulation, a virtual camera, you can find other people's work that you can use for generating data, right? Either it could be in public domain, or it could be you buy that scene. So it's basically leveraging all the work that other people have done to help your training as well. So don't think that you have to physically build that scene yourself. There are other people who might have contributed.
Yes, definitely. So yeah, that's a very good point because you can see in my examples, the controlling the airplane. Of course, I was not building all these things. So and that's one very nice thing of Unity. There is a huge community of creators behind in the Unity asset store. Obviously, not everything is free, but you can. There is so you can find. I will show you a kind of random city generator with traffic system. So you can buy all these assets, and it's really affordable. I mean, it's not free, but it's really affordable, and you can take profit of all this work. So for training or. So yes, I will show you some of these examples here. So we start with the obviously with the 3D virtual cameras. So you will see that behind there is 3 Unity cameras, but obviously we set up with the field of view and all the specs. This is a good example of what we were talking. This is an asset that you can buy in the asset store. I was not building all the ocean system and the Nautilus. I'm not a 3D designer, so but you can. But I was building this head pose new demo on top of this asset. So that's some work in progress.
Controlling the movement using your head in this demo as well.
Exactly, and going underwater too.
And Oak is, Oak is great for this because it's not using the processing power on your machine, and you are able to do this without, because the processing power on your machine is being used to play the game itself. And you don't want to have a lesser experience because the controller is taking away all the processing power.
Especially today with Unity's high definition render pipeline, which makes some beautiful looking stuff, but is very expensive computationally.
Right.
Exactly. That's the point. All these examples I was recording with MacBook laptop. So you can imagine it's not the best friend for the HDA, for the high definition render. And obviously it was possible in part because, of course, all the devices handling all this processing. So just running the scene. So that's great. So here I have, and now about here we start with the 2 examples I was talking. So here you can see how with few drag and drops, I'm creating the most simply pipeline, that is the preview camera pipeline, but everything you do inside Unity. So, and then just run it here. And so this is the preview. And this is the second example, the Inception one. So you can see here it's running the face detector pipeline in the real OBD. but we are feeding with the virtual images from Unity and getting back the results. So this is quite interesting because you can see we can change the lighting conditions in real time and test and validate your model. So changing these conditions. So, and funny enough, this is the same working in low poly character. But yes, so you can run basically in real time. And this is another example with in this case with YOLO. So you can see it's detecting the person. So yes, and pretty much real time. So quite interesting. Maybe
this is running Tiny YOLO, you said?
Yes, Tiny YOLO. And yes, and here is what I was talking about, this city and traffic generator. So here I was installing this OT digital twin on top of this bus. And now it's running inside the city. And here on top left, you can see the results of the YOLO again. So it's detecting basically the cars and the traffic lights. So you can see. So you can validate.
This scene is, it's not a pre-recorded scene or anything. This keeps changing with every time you run the game, right? It is a pretty much random scene.
Yes, yes. This is yes. In this case, in this particular case, everything is in real time, but especially this traffic system is a programmatic traffic system, of course. Yeah. But it every time you play is kind of random. So you have some vehicles around the city respecting the traffic lights, but every time you play is pretty random. So you never know what's going to happen. So.
That's interesting. What's the name of this?
City generator, but I don't have in mind the.
That's okay. We'll put it in the YouTube channel.
Yeah, I can send you.
Okay.
So well, and that's all. So hope you enjoy the keynote, and well, it's now time
demo time.
For demo time. It's always
yes, do the live demo.
Yes. So I have here, let me share the screen again with Unity. So, okay. So could you see my Unity? Yes.
Yeah.
Cool. So basically, okay. So I prepared kind of 3 small demos. The first one is just to take a look more closely to what is or how it looks like the Kauda digital twin inside Unity. So basically, you can see here when I'm selecting the Kauda robot in the editor, you can see a bunch of properties here. Mm-hmm. So you can see, for example, we have a main switch. It's a software main switch to avoid surprises also when it's connected with this kind of security switch. We can enable or disable the inverse kinematics mode, for example, with this checkbox. Obviously, we can connect with USB or Bluetooth connection. And then talking about this counterpart of the real object. So for example, you can see here all the Arduino pin setup. So we have in the real robot. And at the end, for example, you can see each axis. So we can control each axis here. So basically, so I set up, let me, okay, So let me, because now, okay, cool, I can move this. So if I play the scene, so you can see the robot here, and I set up a preview camera of my own camera here. So you can see the real robot. So you can see my version of digital Kauda over here.
So that's live.
That's live.
Yeah.
So let's see. And obviously, it's not going to happen nothing yet because it's not connected and it's not using the Bluetooth and connection. But I want to show. So when we enable this main switch, you can see the robot is kind of activated, and then thanks to the inverse kinematics, we can we can move the robot around. Okay, just using this cube. Okay, so then of course we can enable kind of, well, let's power the robot first because if not going to work. And then if we enable here Bluetooth connection and we start again, so we should see here, okay, so it was connecting using the Bluetooth connection. So now it's initializing, and then if I enable the main switch, it's so you can see here the robot now is active. And then if I'm moving the cube, the robot is following the real one is following the digital one. Okay, so that's a quick demo on this part. The second demo I want to show is yes, so how easy is to create a pipeline inside Unity. So for that, I'm going to create a scene from scratch. Why not? Let's call it demo. And okay, and to create, if I can move this. Okay, so here the idea is we are going to create the mostly, so what you see in the video, so the most simply pipeline, that's the preview pipeline, okay. So we need three things for that. We need the device, we need a pipeline, and then we need the preview canvas to see the image, okay. This is quite easy. Let's call it real OD preview, okay. And for that, of course, we don't need to work from scratch. We have here in Unity what is called prefabs. So it's kind of predefined objects. So we don't need to build them all the time from scratch. And we have here some inside OD devices, we have the real OD device. So you can see when I drag and drop this component over here, so I have the virtual OD here, okay. And we can check several properties. We have here all the resolutions and everything. Let's say we want to create the pipeline when I'm starting the application. And of course, we need a pipeline. So let's create the pipeline. Let's create, let's call it pipeline, maybe. Pipeline. And for that, of course, we have prefabs, but the idea today is to show how to build. So I'm not going to use the prefab itself. We have this script, well, under scripts is kind of a script that you can say it's kind of components, and just drag and drop them. So for example, we have a pipeline here. What is a pipeline? At the end is a list of nodes and links. So then we need, here we have a bunch of nodes. So let's drag the color camera node. And you can see we have some properties here. So we can say color, well, that the name is color cam, why not? The preview, let's choose the standard 300, 300. The resolution is about the camera, but we can put here the 1080p. We can check interleaved, the color order, usually this is VGR, and that's all. So, and then we need an output node, okay, to get the image. So again, just drag and drop this Xlink out node. We can say come out, and the stream name. So let's call it preview. So, okay, we have the two nodes, and then we need a link to connect them. So just again, drag and drop. And then we say, okay, the camera color preview is going to be the output, this out input node. And that's all. So we have this pipeline. Yes, of course, we need to set up. So let's say it's two nodes, one link, just drag and drop. So you can change the definition all the time. And finally, okay, we want to preview the image. So for that, we have another component here, preview. So it's asking, okay, which is the node you're going to get the preview, which is the camera, this one. And then, okay, where is the canvas to see this image? Is the field part we need to create here. For that, let's go for the prefabs because we have a canvas. So we have a canvas here, and you can see we have the typical example. So you have an image and a few buttons to start the pipeline. So to set up the buttons is very easy. Real OD device has a manager, so we can just drag and drop this object here and select OD manager, and it has a method called start pipeline. Cool. And for the stop button, you can do the same. OD manager stop pipeline. So, and now we have this image that is the last parameter we have over here. And that's all. So we have this real OD device here. We need to set up the pipeline. Then we have the pipeline, define it, and then we have the canvas. So we are done, hopefully. So for the canvas, we need the event system. It's not going to work, but we can try. So and we have again here. So you can see the pipeline. So this is an example of this bidirectional communication.
That was great. And that was less than 10 minutes to drag and drop all those components to get this running inside the editor. So cool.
Yes, I forget to mention that in Unity, but it's very common to use node-based UI. So for shaders or for state machines. So the idea in the future is you can use a more friendly interface, not just even drag and drop is quite fine, but you can use nodes and just drag lines. So, and the last thing I want to show you is one of these examples running YOLO.
Mm-hmm.
So again,
for those that don't know, YOLO is a neural network. It does single shot detection of a variety of items, and we'll see one of those here.
Exactly. So it's going to perform kind of this person detection. Okay. So it's the same example you saw in the video. So we just running. So this is running in the real OT device. Yes, sorry.
No, I was saying that it is very meta. You have this virtual inside a virtual inside. It's funny.
Yes,
So
I know.
quick question: this YOLO, tiny YOLO, that it is the tiny YOLO pre-trained model, or you trained it on some of these virtual people?
No, it's just the pre-trained models, like
nice.
the face detector. Yes, yeah, and that's the funny thing. The pre-trained models really works out of the box with
for these virtual characters.
Yes, virtual characters or inside the virtual city. So it was kind of surprising also. So yes, but well, anyway, you can see here I'm moving the person and it's doing the detection. But yes, all pre-trained. So I was not doing any specific.
Nice.
Yes. So custom.
And again, one of the great things about Oak is that it frees up your CPU and your laptop to run all this game logic while running the detector in real time.
Yes, definitely. I'm taking a big risk doing this on MacBook. Honestly, it's not has no graphic cards at all. So definitely it's possible thanks to the process capacity. And yes, that's right.
I said that's great. It's really. I mean, the presentation you just gave us, to summarize, I think it's very informative in the sense that people learned that they should, when the application demands, they should try using Unity-like framework to gather data in virtual worlds, to even simulate their cameras in virtual world, so that they have this very rich library of stuff that people have produced, and they can use it for training their own things. And just this introduction to Unity that opens up people's minds, right? Earlier they were not even thinking about it. Now they start thinking about it. And the other cool thing is a quick introduction to Kauda, which is less than $100, and people can print their own Kauda and try it, especially with kids, etc. My last question was that the OAK-D simulator plugin that you have created, is it available for people to try out, or will you make it open source at some point?
It's here in the keynote that I can share later.
Okay.
So in the last keynote, I added these links to GitHub.
Yeah.
So we are, it's available there. So you can grab obviously it's not the best way. So we are in the process to publish also probably in the Unity asset store. So it's more easy for Unity developers to get access to the plugin. But yes, you can go in GitHub repo, and there is a Unity project, so you can load in Unity, and it should work out of the box. So if it's not working out of the box, tell me, but it should work out of the box. So some examples, obviously, I cannot add these examples where I'm using paid assets. So like the airplane or the Nautilus.
Right.
But all these but I'm always generating these more simple examples where you can execute and test if you have a OAK device. So.
Great. So we are running out of time. So let's first do the question round, and then we'll get maybe a couple of questions. Okay. Phil, do you have a question?
I sure do.
Nice.
Will you remind everyone what they'll win, Satya?
Yes. So the person who wins this question, Phil is going to ask a question. You have to answer the question. The first person that shows up on Phil's screen with the right answer will receive 200 hours of free Azure credit. So that's the prize. What's the question, Phil?
Yep. Again, thanks so much to Microsoft, our sponsors, for providing this sweet prize. So the Kauda robot arm operates with a certain number of axes. How many axes? All right, they already got it. Otto Blom, looks like, is our winner today. The answer was 5 axes.
That's great.
We'll be in touch to get you your stuff. What's that, Steve?
Can we get some few questions?
Yeah, let's get to it. So one of the first ones, we've got this one a couple times, asking about the latency between puppeting in the virtual space and then translating into real life over USB and Bluetooth. What kind of latency can people expect with that?
With kind of?
Like how long? What's the time delta between making a move in the virtual space and seeing it in real life, etc.?
So really, there is no so over Bluetooth or USB, because I'm connecting directly Unity with Arduino, so you can connect with the USB Arduino port, so it's instant, so there is no delay. But about the accurate simulation, so how you translate. So at the end, for example, when you use inverse kinematics, you cannot, if you try to update at every frame the position of the moving all the axes, is not really working fine. So what is implemented, and maybe that's why you can see a small delay, is until there is no kind of nice movement, there is no an action, whereas the inverse kinematics is computing all the 5 axes. So what is the movement of each axis to translate from the initial position to the last position. But there is no delay, even with Bluetooth. The augmented reality smartphone application you saw, in fact, is running only on the iPhone and connecting directly with Arduino Bluetooth module. So there is not even host between.
But the example you showed with the aircraft, where you were controlling the aircraft with your face movements, was there a delay? Like, is it 10 milliseconds? What is there should be some.
50 milliseconds, 10 milliseconds, something like this.
And you can see, well, you can see some small delays, but it was my laptop struggling to record the screen and running the scene, like with the Nautilus. With again, the MacBook Pro is not great with high definition render.
So you can get it almost real time, maybe 10, 20 milliseconds. Okay.
Yes, definitely. In fact, with the blocky character and the head pose, it was the same. So I was, just to avoid a small flick, I was trying to make it smooth. But in the GitHub repo, you can see in real time, and there is no delay at all. So
it's awesome. So if you've got a beefy enough system, it'll eliminate that latency, is what you're saying.
Yes. So it's definitely so.
Cool.
The nice examples demanding more, but
right. So we've got another question here about how long did it take you to assemble it once you had printed all the parts and had the non-printable parts?
Not so much, honestly. So, well, you were seeing it's pretty small. There is only 4 NEMA motors, stepper motors. The same motors for the 3D printer. In fact, it's quite exceptional. So,
nice.
That's nice. If one of them breaks, you just take one off the printer.
Yeah, exactly. So you have 4 now replacements for your 3D printer for free. Well, not for free. And so I would say maybe it takes, depends on your ability also with reading the schematics and if you know about Arduino before or not. So maybe it could take 1 month, maybe if you have all the, I mean, you can find all the, obviously you can 3D printed everything. The other parts you cannot 3D print it. It's very easily to find on Amazon, whatever. So it's when you have everything, maybe 1 month, I would say, in your spare time. I mean, it's not a long time. It's not.
Yeah,
I'm not very good building, so I'm not a good reference also. So I was struggling to.
Yeah, well, and you're, I think maybe this might have gotten lost a little bit, but this is only a 2-person team, folks, and they've put out this incredible open source, work, and the competition is not even over yet. So it's really impressive. Where can people hit you up with questions, or if they want to know more about this? What's the best way to contact you, Gerard?
So yes, in my case, I'm spending more time right now in LinkedIn. Probably is the best way. In the last slide of the keynote, I added some point of contact, but LinkedIn, Twitter is so Giovanni. I added the Giovanni also Twitter account, but LinkedIn, Twitter is the best way to contact.
That's great.
Great.
We'll put that information in. Yeah.
Yep. Exactly. We'll put that in the post. Yeah. I guess we're out of time. You want to take us home, Satya?
Yeah. Thank you so much, Gerard, for this awesome presentation. We learned a lot, and thanks, Phil. For all the viewers, please check out all the material that Gerard has published. We will be able to share the slides, as well as we will also share all the links that go with this presentation. And finally, just a quick reminder, our Kickstarter campaign starts on May 18th. Check it out. Thank you so much. Bye.
You can find that on opencv.org.
Yes. Thanks.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by Microsoft Azure and Intel, sponsors of the world's largest spatial AI competition, OpenCV AI Competition 2021. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.